Today we're going to cover section 3.6, which is variation. There's three different types of variation. There's direct variation, which has equation y equals k times x. There's inverse variation, which has equation y equals k over x. And there's joint variation, which is y equals k times x times z. In these equations, k is called the constant of proportionality. So in these equations, constant of proportionality, that is k. So we're going to go through and we're going to do a bunch of examples. First of all, just writing out the equations based on these keywords, direct, inverse, and joint. Then we're going to see what about some equations with numbers. And then the equations with numbers is kind of the first third of you guys' homework. And then the sort of word problem types, that's the rest of it. And we'll see that the word problem types are really not much different than the types where you have symbols and numbers. So this section is pretty easy. Okay, let's first of all just figure out how to get some, if we have a couple situations here, let's figure out how to get the equation of variation. So this is going to be what's called equation of variation. So we're going to get kind of some setups with the words, and from those words, we want to write out what's the equation of variation. So let's do about 3 or 4 of these. We'll say A varies inversely as R. M varies directly as the square root of, let's say, t. F varies jointly as P and Q. And finally, let's say B is inversely proportional to the cube of C. So you look through, these are kind of phrased one way. You'll either hear the words varies directly or varies inversely, varies jointly, or you'll hear the word directly proportional, inversely proportional, jointly proportional. But you'll still see the keywords directly, inversely, jointly. So we have A varies inversely as R. If we look at the inverse equation, inverse says you're going to divide into the K. So A equals K, and we're varying inversely as R, so the R divides into the K, and that's our equation of variation. M varies directly as the square root of t. So we have M equals K, and then the square root of t, we got to see, do we multiply or divide, or what do we do with that? Our keyword is directly, so this is direct variation. So that says we're going to multiply the k. So the square root of t multiplies the k. That's our equation for part B. Part C, F varies jointly as P and Q. So F equals K. And in joint variation, the two things multiply to K. So it's F equals K times P times Q. And finally, so jointly was a keyword there. Finally, B is inversely proportional to the cube of C. So inversely proportional. Inversely is our keyword. Inverse says divide into the K. So B equals k divided by the cube of c, which is c to the third power, c cubed. So that is how we generate the equation of variation. The homework that we're going to deal with is going to have you guys use these equations with numbers. So we'll work a couple examples seeing what that looks like, and then the rest of the homeworks has word problems types, so we'll look at some word problems and see that the word problems are pretty easy. So for this example, let's say t varies directly as the square of a. T equals 4 when a equals 10. Find t when a is 2. So the pattern that all these fall into, so everything else in this lesson, the pattern it's going to fall into is get the equation, plug in the values they give you to figure k out, then put the k value back into the equation along with any other information and figure out what they're asking. So t varies directly as the square of a. Direct variation is multiply into the k. So t equals k, and the square of a, since it's direct variation, the square of a multiplies to the k. Now they give us t is 4 when a is 10, so we put 4 in for t, and we put 10 in for a, and since a is squared, the 10 gets squared, so we get 4 equals k times 100. Divide the 100 across, so 4 hundredths equals k. 4 and 100, 4 hundredths divides down to 4 divided by 4 is 1, 100 divided by 4 is 25. So 1/25 is our k value. So our equation now is t equals 1 over 25 times a squared. So for the final bit, they say find t when a is 2. So we say here's our equation. We rewrote our equation with the k value plugged in. Now we're supposed to put 2 in for a and see what we get. 2 squared is 4. 4 times 1/25 is 4/25. So this turns into t equals 4 over 25, 4/25. So this is kind of the pattern that everything in this section does. Get the equation, take the information they give you, figure out the k, plug the k in, look for the last bit of information, plug it in, and figure out the variable they want. Everything in this section is going to have that pattern. Let's look at another one. Say c varies jointly as m squared and the square root of n. C equals 1 when m equals 2 and n equals 4. Find c when m is 3 and n is 1. So we say figure out our equation first. C equals k. Joint variation is they both multiply, so it's k times m squared times square root of n. That's our equation. Now we plug in the values they give us to figure k out. 1 goes in for c. M is 2, and since m is squared, the 2 gets squared. Square root of n is 4. So we get 1 equals k times 4 times square root of 4 is 2. So 1 equals k times 8. We divide the 8 across, and we get 1/8 is our k value. So now what we need to do is we need to rewrite our equation with the correct k value plugged in. So c equals 1/8 times m squared times square root of n. So now they tell us m is 3, so plug 3 in for the m. And they tell us n is 1, so we put a 1 in for n. So we get c, this turns into c equals 1/8 times 9, and square root of 1 is 1, so multiply 9 by 1 just leaves it 9. 9 times 1/8 is 9/8, so c equals 9/8, and we are done there. So again, it falls into the pattern of get the equation, plug in to figure k out, then substitute k in, plug in the rest of the information, figure out the value you want. We'll do one last one of these types, and then we'll do a couple word problem types and see that it's just the same, and then we'll say that that's good. All right, for this one, we're going to say R is inversely proportional to B. R equals 5 when B equals 2. And this time we want to find B if R equals 7. So R is inversely proportional to B, says R equals K times inversely. Inverse means divide. So R equals K divided by the B. So this is our equation. R is 5 when B is 2. Multiply the 2 across. 5 times 2 is 10, so 10 is our K. So R equals 10 over B. Now we want to find B when R is 7. So this time, normally they give us the B and figure out the R. This time we have to put 7 in for R and figure out what the B value is. So I'm going to multiply the B across, so I get 7 times B is 10, because I need the B out of the denominator there. Then if I want the B by itself, the 7 divides back across, and we get B is 10 over 7, and that wraps that one up. So same pattern, get equation. Once you know the equation, find K. Once you find K, plug K in and the rest of the information they give you and figure out the variable they're asking for. These last two types will be word problem types. These are kind of what you guys will see a lot of in your homework, and we'll see even though it has words and word problem, it's really about the same level of difficulty as the types we've just been working on. So for this one, we'll say force varies directly as acceleration. We'll say if the force is 10 newtons, comes from an acceleration of 7 meters per second. So force of 10 newtons is generated from 7 meters per second squared. Then we want to know what force will be generated from 8 meters per second. Sorry, I said meters per second. Meters per second squared is acceleration units. So we got our force. We got our statement about the equation. So force varies directly as acceleration. Let's use F to represent force, and let's use A to represent acceleration. So direct variation says the A multiplies into the K. So F equals K times A. Force of 10 newtons is generated from a 7 meters per second squared acceleration. So 10 equals K times 7. Divide the 7 across. We get 10 sevenths is our K. So kind of going through and rewriting our equation with the 10 sevenths replacing K, we get force is 10 sevenths times A, the acceleration. So now they want us to know what force is generated from 8 meters per second squared. So we replace A with 8, and our force is 10 times 8 is 80, divided by 7 newtons, and we get 87th newtons. You guys could put that in a calculator to get it as a decimal if you wanted to see what that was, but we can see even though it has kind of words, it still use a letter to represent each of the words, and it basically boils down to the same types of things we've been working on. Get the equation, plug in the numbers, figure k out, plug in k, plug in the rest of the information, figure out what it's asking. We'll do one more of these, and that should do it. So we'll say in a process, temperature varies inversely as the square of voltage. And we say 5 volts creates a temperature of 70 degrees Fahrenheit. So 5 volts creates a temperature of 70 degrees Fahrenheit. And we want to know what temperature will 9 volts create. So 9 volts creates what temperature? So again, we look for our keyword. This time we're varying inversely. Temperature, let's use T. Square of the voltage, let's use V for voltage. So temperature varies inversely. Inversely means we divide into the K, and it's the square of the voltage. So it's voltage squared. Now, they tell us 5 volts creates a temperature of 70. So the temperature is 70 when the voltage is 5, and the voltage is squared because we varied inversely as the square of the voltage. 5 squared is 25, so we get 70 equals K over 25. So the 25 multiplies to 70. Let's see what that is. 25 times 70 is 1750. So we get 1750 is our K value. So now we can rewrite our problem. T equals 1750 over V squared. And we're saying, okay, now what if the voltage is 9? What's the temperature? So we just plug 9 in for the voltage. We get temperature equals 1750 divided by 9 squared. 9 squared is 81. So temperature is 1750 over 81. And then that's degrees Fahrenheit. Kind of like to see what is that actually. So let's do the 1750 divided by 81. And we get that's 21.6 degrees Fahrenheit. So basically, temperature the larger the voltage gets, the smaller the temperature gets. And we can see that the for these, basically, you look through. There's 2 ways they'll ask stuff. They'll say so and so either be varies directly, varies inversely, varies jointly. Or it'll be so-and-so is directly proportional to, is inversely proportional to, is jointly proportional to. So you look through and find the keywords direct, inverse, or joint. That'll get you the equation. Plug in information to figure the K value out. Once you know the K value, get your equation with the K value. Plug in the rest of the information and figure out the variable they want. And that is basically how the section works. So you guys should have everything you need to do section 3.6 assignment.